Hello and welcome to this film, which is about covalent bonding. It's the first of four. This one's just an introduction to the topic. You've probably come to this one having just watched some films about metallic and ionic bonding where atoms are quite keen to give away electrons. This is dealing with atoms that aren't so keen to do that. And hopefully by the end of this film you'll know how to spot elements that would rather share electrons than give them away or take them, and then form covalent bonds. And you'll know the definition of a covalent bond and a molecule, and how we can represent covalent bonds in molecules using diagrams. These definitions are so important because if they're not understood correctly, they basically mess up explanations all throughout the bonding topic. Okay, so first of all, how do we spot a covalent molecule? Well, as we saw before, if you want to spot an ionic substance, it's going to be a combination of a metal with a non-metal, so an atom that wants to lose electrons combined with one that wants to gain. A metallic structure will just be made of metals, so that is atoms that want to lose electrons. Well, we're now looking at elements that want to gain electrons, so the elements with high electronegativity. Okay, those ones over here that attract electrons strongly. Okay, the non-metals. So if ever you've got two non-metal elements combined together, they're going to form covalent bonds because they're not keen to give electrons away. They want to gain electrons to fill their outer shells. So just to have some simple examples, you could have HCl. HCl is made of two non-metals. Sulfuric acid, I've just chosen two acids there, but we could have ammonia or any combination of two non-metal elements, and that means you've got a covalent molecule. Okay, so look out for combinations of two non-metal elements. What is a covalent molecule? Well, this leads us on to these really important definitions. A molecule is defined as any two or more atoms that are held together by a covalent bond. Okay, so it doesn't have to be a compound. Okay, so O2 is a molecule in the same way that H2O is a molecule. You don't have to have two atoms, you can have two or more. You could have glucose, for example. So here we've got three different kinds of atoms, but 24 atoms altogether making up this one molecule. Okay, because they're held together by covalent bonds, that makes all three of these things covalent molecules. How can you tell they're held together by covalent bonds? Because they're all non-metals. Definition of a covalent bond, well, that is the mutual shared attraction, or the mutual attraction, to put it more simply, the mutual attraction of two nuclei for a shared pair of electrons. And it's got to be a pair. So not just shared electrons, but a shared pair of electrons. Okay, so make sure you remember those definitions. They're really important, because if you start talking about intermolecular forces where there aren't any molecules, then you're immediately going to be losing marks. Okay, and finally, just a couple of different ways that you might see covalent bonds represented. Okay, in electron dot diagrams, we often use dots to represent electrons, unsurprisingly. Okay, so here's a hydrogen atom with its one electron shown as a dot, carbon atom with four. Here's a water molecule, which is hydrogen atoms sharing electrons with oxygen. Okay, so you can show them as pairs of dots. You could show them as pairs of crosses if you prefer. Okay, so there's no difference between those things. Or you can show a pair of electrons as a line. Now, in this molecule here, the bonding electrons have been shown as lines and the other ones have been shown as pairs, but that could just as well be shown as that. So anytime you want to show a pair of electrons in a diagram, if you draw a straight line, that's what is understood to mean a pair of electrons. And it's a bit quicker if you're in an exam than drawing lots of dots or lots of crosses. Okay, here's a double bond, because there's two shared pairs of electrons between those two carbon atoms, and here's a triple bond. Okay, three shared pairs. Alright, so either with lines or with dots, doesn't really matter. You can use crosses, you can use any shape you like. but I think the quickest one is to go for lines. Now, a good place to go next would be to watch the film that is the second in this series about covalent bonding, and that is the one, let me see, it's electron dot diagrams. Covalent electron dots 1, I think, would be a good place to go next.